To start our pH meter reading lab, we began by calibrating the pH. We started by spraying the probe with distilled water and then placing it in a pH 7 buffer solution. On our tablet, we put in the known value of the buffer solution, which was a pH of 7, and applied it. This process is sped up a bit because sometimes it can take a while for the relative stability reference number to stabilize, but whenever it comes to a consistent number is when you can enter the known pH, which was 7. Next, the same exact process was followed, only this time we used a pH buffer of 4. By calibrating the meter using this 2-point calibration method, it makes the probe able to read the pH value of many different solutions. We then use the calibrated pH probe to find the pH of a 0.2 molar solution of hydrochloric acid. After that, we use the calibrated probe to find the pH of known and unknown solutions. Strong acids completely dissociate in solution, while weak acids only partially dissociate in solution. In the case of weak acids, most of the acid exists in solution as molecules, not ions, unlike the case of strong acids. With weak acids, this forms an equilibrium process between the H+ or proton, where some molecules are forming ions and some ions are forming molecules. An equilibrium forms between the proton acid and the ion conjugate base of the acid. To minimize pH changes, a buffer can be added. The buffer will accept protons, thus forming water, neutralizing the acid, and only minimally changing the pH. A buffer is a solution that can resist pH changes when it is introduced to an acid or a base and works by neutralizing the acid or base to maintain a moderate pH.
Do you want to go ahead and do yours?